Today's problem was submitted by a viewer, and it says, which of the following is smallest? And we're given five numbers. I am notoriously bad at some of these questions. My instinct is going to be to square these quantities and see what happens. But we're likely going to keep ending up with things that have square roots in them all over the place. So maybe there's something a little bit more intelligent that we can do. I think maybe something like, so if a is equal to 10 minus 3 times root 11, then 3 times root 11 is equal to 10 minus a, and we can square that. And then maybe that doesn't seem like it'll help very much. Okay, what happens if we square these numbers? Nine times 7, 63, minus 2 times 8 times 3 times root 7. 64 plus 63 is 127 minus 48 root 7. See, it's not really helping. Which of the following is smallest? Maybe this is the way to go, rewrite things in this way and see if I notice that this is 1 less than that squared. This is also 1 less than that squared. So let's keep going with this. Mm. 16 times 5. Sixteen times 3. 48. Okay, so what I have then is 99 is equal to 10 minus a squared. I have 63 is equal to 8 minus b squared. 24 is equal to 5 minus c squared. 80 is equal to 9 minus d squared. And 48 is equal to 7 minus e squared. So conceptually now what's happening is, these are all 1 less than a square, and they happen to be 1 less than the square of the number we're subtracting from in each case, right? 5 squared is 25, 1 more than 24. So we're kind of asking, in each of these cases, which number do we have to subtract the smallest amount from to go down, to reduce from a square to one lower number. And that's going to be for the case for the larger this number is, and the subsequent the square minus 1 here, the less we have to take off of this to make that true. What am I trying to say here? The answer here is going to be A. This is the smallest one. How do I explain this better? I mean, the squares get farther apart the higher you go. And so you know, let's take 2 squared and 3 squared. Going from 9 down to 8 is a relatively large change compared to going from 100 down to 99. So yeah, that's the best way. That's the best way I can try to explain this. Maybe there's something graphical I could write down with, you know, a plot of x squared or something like that. That might help a little bit. So if I take the function x squared, yeah, maybe this is a better way of seeing it. If I have 2 different values of x squared, if I want to decrease this by 1, if I want to move that down by 1, then I need to move the corresponding value of x to the left. But if I want to move this down by 1, then I have to move this value of x farther to the left. The distance I have to move to the left is greater than the distance I have to move this one to the left. And that's because of the relative steepness of these two things. I think that's the best way I can explain this. Yeah, I'm usually really bad at these types of questions, figuring out which is the smallest of all these. Often it boils down to like a pairwise comparison of things, and maybe you can do that somewhat intelligently. But here you have sort of this general thing that kind of works for all of them in the same way. And then it's just some reasoning about how squares, you know, spread apart as they get bigger and bigger. Yeah, not much more to say about this one. Thanks for watching.